Tutorial sheet 1, question 9. We are given the impulse response of a system, which is h of t is equal to e to the minus t times u of t, and we're asked to find the unit step response. So what we have here is that we're going to put a signal x of t into a system which has an impulse response h of t, and we're going to get an output response y of t. So our x of t in this case is equal to an impulse, a step. So x of t is u of t. Now the convolution integral says that y of t can be equal to x of t convolved with h of t, or h of t convolved with x of t. Doesn't matter which way around you do it, you can do it either way. But it's actually easier in this case to actually use this second one, rather than manipulating this equation and having to put t minus tors into here. You still get the same answer, but you can actually, it's easier to do this equation here. So what I'm going to do is write down the integral minus infinity to t of h of tor times x of t minus tor d tor. So that's the convolution integral that we need to carry out. And if we put those two equations in, we're going to get the integral of minus infinity to t of e to the minus tor u of tor, so just replacing t with tor, multiplied by u of t minus tor d tor. Now this might look a little bit complex because we've got three functions, each of which is a function of tor, which is our integral component. If we look at these two functions, u of tor and u of t minus tor, if we actually sketch those as a function of tor, well, we know that u of tor is just going to be a function which is 0 and goes to a value of 1 and remains at 1 to tor is in infinity. U of t minus tor, well, the minus tor essentially means you have a flip, so it flips over on the y-axis. So if I have some value t, which is just a time shift, what I'm going to get here is a function that looks like that. So that is u of tor, and that one is u of t minus tor. So the only region in tor where this is anything other than 0, it's 0 here and it's 0 there, is in this region between 0 and t. And the value of that product of u of t minus tor and u of tor is just 1. So I can change this integration between the limits of 0 and t of e to the minus tor multiplied by 1 d tor, which is now a very, very, very simple equation to manipulate, and that will give you your final answer of 1 minus e to the minus t. You must remember, of course, to multiply that by u of t, so that nothing exists before time t equals 0.